What?
On A.
It's,
Solution.
Did it say positive?
yeah, weak but positive
association of nonlinear.
because it's going that way.
I hate that. Yeah, so include positive. I disagree with that assessment, but they do say positive, so include the direction. Positive. Did it say weak to moderately strong?
It said weak but
Weak. But and then shape would be nonlinear curve. Okay. Any unusual aspects, and they didn't look for it on this one, but are there any unusual aspects, any points that we feel like seem to be a little out of the pattern?
The very top of
The very top left?
the far right.
I would say this might be considered a what? A potential outlier. This could be considered a high leverage point, right? It's far away horizontally from everything else. Those are things we would want to recognize. Okay? Questions, comments, concerns through A. High leverage, right? Remember, horizontally away, it's high leverage. And say it again.
I think dealing as an outlier.
So remember, if it's an outlier, it's vertically far away. And if it's a high leverage point, it's horizontally far away. Because like, think about it. If I were to take this point out, how nonlinear would it now be? It would be super nonlinear. Like it could almost be linear. It's this one data point that's really making it nonlinear. So that's an influential observation as well. They didn't expect that on this one, but that is a part of the new course and exam description, the outliers and high leverage points. So they would ask for that these days. So remember, 5 things: direction, strength, shape, context, and unusual aspects. Okay, B. One of the sewing machines substantially affects the appropriateness of using a linear regression model. Report the approximate price and quality rating. The one on the far right, right? So maybe $2,200 with a quality rating of 65. And why is that one influencing it? No? Does that make a mistake?
No, I just mean that's so crazy. Like
Made it harder?
no, just the quality rating versus the price.
Oh.
Like, that's crazy.
Yeah, right? It happens though. There's sometimes where you're like, this is super cheap and it's great. And then there's sometimes where it's like, that's probably some super fancy name brand that produced something crappy, right? So based on all that, why would that be the point though? Not just that, because remember, this is about non-linear, right?
It kind of is what makes it nonlinear.
It is, but like, what about it makes it non-linear? It's horizontally to the right and...
Influencing.
Huh?
High influence.
Come on, think about, like, y'all are making that harder than it has to be. You're trying to use that super fancy statistical language.
It's away from the rest of the data.
It's away from the rest of the data and also what?
Pulling the line.
Okay, if this wasn't here, what would we say? That
So linear.
it's linear, probably, it's somewhat linear, but it's also increasing as we go to the right.
Yeah.
Did that increase?
No, it makes it a decrease.
Right, so like that's the thing is that it's a higher price but lower quality, so it created that curved shape, right? Like that's what we want to recognize is it's a higher price but curved shape. You good with that, Aaliyah?
yeah.
Okay. So he's only interested in buying one of the 14 sewing machines, only wants the machines for which there's no other machine that has both a higher quality and a higher price, or lower price, sorry. So what has the highest quality here?
The 182.
The one around 82, right? Is there anything cheaper at that price?
No.
No. What's the cheapest price?
The one at 65.
And is there anything with a higher quality at that price? Right, so highest quality point, cheapest price point. Okay? I know you weren't here to be able to do it yesterday or to get these, but take what notes you have, but you also have like the solution set, make sure we're engaging, talking to it, right? And again, sorry for rushing, but you know,
Not sorry.
we want to, what?
So you're not sorry.
I am sorry, but we got an AP exam and we gotta wrap this up. What was the other one? It was 20, 16 that I assigned last night?
Yeah.
Alright, was it number 6?
Yeah.
So this one was an unusual one, but, say again,
I like 2016.
you like the 2016?
Yeah.
So notice this is a number 6.
It was a good year,
When we talk about number 6, they traditionally start with something that you know. And they end with something that requires you to extend your knowledge. So, this newspaper claimed that the more semesters needed to complete an academic program at the university, the greater the starting salary, right? Does that scatter plot seem to support their answer?
Yeah,
No.
it's positive.
Yes.
I mean, like if I were to draw a least squares regression line or some kind of regression line, I mean, I could see it's overall increasing. It's not a beautiful, perfect relationship, but it is overall increasing, right? Bryson? See that shape? You good with me? You locked in? Okay. So the table below shows computer output. Now I need y'all to pay attention to this because some of us did struggle with this part yesterday on the demonstrated understanding that we're going to go over. So, Logan, where am I going to see the slope of the least squares regression line from this problem? So to the right of the semesters. Remember, what does the COEF stand for, Aaliyah?
Correlation coefficient?
So not even correlation coefficient, just the second part of that. So just, not correlation, just
The coefficient.
coefficient, remember, right? Bryson, what do we mean by a coefficient? So this might be something we need to pay attention to. Breaking it down, going back way in the past. Bryson, there's only one coefficient in that expression. What is it? Ooh, so close. Not the x, that's a variable. 3. So a coefficient, right? What do we mean by that? Number being multiplied by a, what do we call this thing? A variable, right? A coefficient is just a number being multiplied by a variable, right? And so what do we call this 2 here? That is a constant, right? Which they call it a coefficient of the what? Constant. Okay? And so what would be my slope? What is the coefficient of a variable in this computer output?
Oh, sorry, 1.154.
Okay. So the coefficient of my only variable is this number. And Bryson, just because I saw this on your demonstrating understanding, I want you to be careful about this, and everyone needs to be careful. I just saw it on yours. What does this SE stand for? That's, say it again? That's standard error, right? We're not dealing with standard error. When you do inference procedures, you deal with that standard error a little bit, and that is a part of the AP exam, but it's 2 to 5%. We ain't got time for it, okay?
Yes, sir.
So, we're not going to use that. We're just looking at the slope. And Peyton, I know you weren't here yesterday, but do you remember the recommendation that I made to help y'all interpret the slope? Because they asked us to interpret the slope in context. Okay, so I'm going to come back to you in a second. Logan, what was the recommendation I made?
You said strong. Is that strong?
I think what is Logan thinking about when he says strong? He's thinking about the what?
Correlation.
Correlation coefficient, right? R. That's that
All
strong.
of them together. Like the
Well,
strong positive.
That's the correlation coefficient. I'm talking about the slope, right? Part of it. I'm going to come back to you as well, then I need to pay attention to this. Lexi, do you remember the recommendation I made here for slope?
Like how to interpret it?
Yep.
As something increases by 1. Is
So
that kind
so
of?
you're getting into the interpretation, but I'm looking for something about how, there was something that I recommended that we do first before we try to
Put
actually
divided by 1?
say again.
Divided by 1?
Okay, so 1 we need divided by 1, but there's something else with it.
The change in
The change in,
the predicted Y.
there we go. And so what are we predicting? The
Yeah.
salary, right? Predicted salary?
Yeah.
So the change in the predicted salary, divided by the change in
X
X, which is,
semesters.
okay? So Logan, Peyton, right here. I need y'all to see this. Remember, if it's the change in Y, or Y hat in this case, divided by the change in X. When we put some context to it in this format, the students who interpreted correctly yesterday were the ones who wrote this out. And there was a couple who didn't have to write it out, but if you write it this way, it's going to help you remember, right? Because now I just have to write it as a sentence. For every what? Increase of what?
Of one or by one
By one what?
semester.
Okay, so for every, you can say it that way, or just extra semester in college, right? That's the change in X, that's my explanatory variable. With me, Leah?
Yes.
Change in my explanatory variable. For every extra semester in college, what is happening?
The salary increases by 1.159.
Does that make sense? Was that, like, the salary only increasing by 1.15?
It would be euros.
There we go. So, and is it the salary for sure that's increasing by that much?
The starting salary.
It's the starting salary. There's another key word you're missing, unless I just didn't hear it.
Predicted.
Thank you. Remember, there's a reason why we put this hat here. The predicted starting, so go all the way back to your full context, salary increases by, so that'd be $1,159.40
Or
on average, or euros.
euros.
Thank you. And so it's a type of average. Just saying predicted is usually fine, but saying that on average can help your evidence of understanding. Okay, so make sure. I need the 20, is this 16?
Yes, sir.
I know I got a million fingers. There you go. Okay. All right. So I'm not going to go through every bit of this, but I do want us to look here now, because I want you to think about it. Traditionally, who makes the best starting salaries?
The ones.
Doctors, engineers.
Sorry. In a single degree, who is typically going to make the best starting salary?
Are we talking about this case?
No, just in general. Think about it logically.
Doctors?
No. Even when I talk about all doctors, right? Which of those doctors is going to have the best starting salary? When you talk about all engineers, who's going to have the best starting salary? Huh?
Anesthesiologist?
Dog.
Master's degree people?
Surgeons.
Those got the most education.
Sorry, I need to rephrase this. Listen, top of the class or bottom of the class?
Top.
Thank you, there we go. Okay, so top of the class is typically going to earn the best salary, right? Does the top of the class usually take more semesters to finish or less semesters to finish?
Probably less.
Probably less,
Oh, yeah.
right? Top of the class typically takes less semesters. So how in the world are we getting this data where it takes more semesters, but you make more money?
Because you're comparing three different majors.
Because apparently, and this is why you always need to ask questions, when things don't line up data-wise, you might want to ask another question. Look at the back side of this. When I look at my business majors, and I only look at my business majors, is that still an increasing relationship?
No.
Probably not. It's
The
not.
more semesters they take, the lower their starting salary. If I look at physics majors, and just at the physics, is it still true that as it takes more semesters, they make more starting out? No. What about chemistry?
Oh, no.
And so I just want you to see that, and this is how this becomes a question 6. Right? A and B were those things that we've done in the past. Very straightforward. But now, based on the people in the sample, describe the association between starting salary and number of semesters for the business majors. Just looking at the business, how would I describe the association?
Strong, negative, and linear.
Strong, negative, and linear. Make sure you have your context and
context.
no potential influential observations. Yes.
Why don't you just have like the labels on the side of windows?
Because we're now on the part B, C, and D. Okay. Based on the people in the sample, compare the median starting salaries for the three majors, right? Notice, how are we going to find the median starting salaries? Do we do that very often with the linear regressions we've done up to this point?
Just look at it.
Just tell them up.
Just looking at it, just kind of guessing, right? So, and it doesn't even have to be perfect, but, I mean, median salary would be somewhere in there. We have 4 and 4. Median salary would be in here. And median salary would be in here. So, when they say, and I need you to remember this because I saw this on the mock exam, they're not asking for the full cuss, but when they ask to compare the median starting salaries, what do you need for sure?
Medians.
Thank you.
And context.
And context.
And comparison.
But when you compare, this is what I need us to focus on. When you compare, what do you need to do?
Compare them directly.
Compare them directly. Which one's the greatest? Which one's the second greatest? Which one's the lowest? You have to directly compare the median starting salaries. And you don't need the exact. You can just say the median, the greatest median salary is for the chemistry majors about, I don't know, 56,000 euros. Right?
Yeah.
So context, direct comparison, make sure you have that. Alright, I'm going to skip that one just so we can get to. Let's look at the demonstrator. So what we're going to do today is we're going to do the demonstrate your understanding analysis. Then you're going to get a chance to do another AP free response question. I'm going to have y'all work on that in small groups because it is a question 6. And I want it to be our final review for the test on Monday. And then we're doing exactly what you've been asking for, Deacon. What are we doing today? You've been asking for it for like a week. Thank you. We're doing chi-squared today.
I've been asking.
Inferences with multiple variables and populations. Okay, so I need you to get the demonstrated understanding out from yesterday.
Gosh.
I need you to look at it and see. I tried to give notes throughout, but look to see what questions you need to ask
All of them.
for clarification. Dude, you had lots of E's. You just
I
trying to
said 8
complain.
X's
You're
right
pulling a
here.
Michael here. Stop doing that.
X,
So are we
X,
keeping
X.
Can we go
like
with
So, sorry, look at the first set of true, false, or the false statements.
Are we keeping
Number
the
2.
scoring guidelines?
Say again. Yes, you can keep the scoring guidelines to help you study. Okay?
Yep, for that reason.
Because you're going to study.
I need to.
Alright, number 2, I heard that one. Any others?
I thought it said
That's-
casual.
Yeah, number 6 too.
2 and 6? What were you saying?
I thought it said casual, not causal.
I was wondering.
Yeah,
Alright.
I said casual. I thought I said casual.
Causal. I did not misspell that
I
one.
didn't know it.
So number
That's
2. Hey guys.
I thought it said
Hey.
casual.
Listen.
I'm dyslexic.
Okay, but we need to focus. Slopes and correlation coefficients of the least squares regression line for predicting y from x, and of the least squares regression line for predicting x from y, right? So when the variables that are switched are the same, right? How do we calculate r?
The sum of z of x and the sum of z of y.
So not the sum of z of x and the sum of z of y. It's the sum of z x times z y. Notice.
What? I don't even know what that means. Z? Oh wait, what am I saying? Yeah, I'm stupid.
Thank you. Just slow down and think for a second. You're not stupid. You're just not slowing down.
I'm blaming it on calc today.
Divided by standard deviation, right? Standardized test score. So in that case, does it matter if x and y are switched? No, we're just multiplying them. Okay? So if I switch my variables, is that going to change the correlation?
No.
No. But what about the slopes?
If you're reciprocated,
Say it again.
it'd be reciprocated.
It'd be the reciprocal, right? Remember, slope is the change in y divided by change in x, right?
Can you give me a picture?
But what we literally just did is we switched our x and our y, so the slope would now be the change in x divided by change in y, which technically that would now be my y. So if you put context to it, let's say it that way, and I probably should put context to it. So the change in, let's say, deer population
Bears.
divided by the change in trees. Well, if I switch those two variables, it's now going to be the change in trees divided by the change in Deer population.
Should we do a visual representation of that?
No. What do you mean?
Like, put that, like, on the graph.
So the tree's deep, I guess actually it should be flipped, but notice if I switch, so here's my deer population. Oh, I said trees first. And then deer population, each of those X and Y values will switch, right?
Yep.
And so what'll happen though is that whatever the number of trees here for my input becomes just the output, right? And so the correlation coefficient with those z's isn't going to change because it's just zx times zy, but the variables will switch and the slope. Oh, did I not give you the demonstrate your understanding? Tell me these things so I don't forget. You need to take notes so that you can crush it on the test. All right. So, number 6 I heard as well.
Yeah, please.
Guys, what is necessary to establish a causal relationship? An experiment.
Well, I thought it said casual, I'm so confused.
Well,
I read you.
guys, we gotta be careful because I will say this. I usually say cause and effects, but the AP exam does say causal sometimes.
What does that mean? What do you think about it, Tom? I've never seen it.
Causation.
Thank you.
I know what it means, I just don't like the word.
Okay.
I low-key thought it said casual.
Okay. All right.
Yeah, me too.
What about the next two
That's
questions,
okay.
the multiple choice?
9, please.
All of them. I'm just fine now.
New wave A?
No, say again.
New wave A?
They said
No.
That's
two
not one of the
questions.
next two, my guy.
Oh, wait, might be.
I couldn't explain what you asked.
Right,
me.
yeah, it's
What I
not
really
really
knew
somebody
was
that
for each
explanation on that.
increase in temperature.
Right, so remember my slope, right,
It's in like-
is the change in the predicted Y, which is the predicted chirps, divided by the change in degrees Fahrenheit. Guys, if you write that out every time for my slope, it makes it super easy to interpret. Okay? So that's why it was B though. Write it out and it'll help. And then the next one, how do we always calculate a residual? Actual minus predicted.
Yes.
Yeah.
I realized that yesterday after taking the test, and I was like, oh my goodness, that was so easy, and I missed it.
So it's okay. Learn from it. Do better in the future. That's all we can ask. So remember, AP, actual minus predicted. And Bryson, how are we going to find our predicted?
You find your predicted with the number, put the 21-year-old and sub it in for X in the equation.
Right, so notice T is literally the age, right? So we're going to substitute in for age. That gave me 29.6, and we just subtract them. Right, Joseph? And when we get a negative, we leave it as a negative and not switch it to a positive. You killed it. I looked down and I was like, you have negative 4.6, and you picked 4.6. And I think you erased the negative 4.6, didn't you? All right, do we need to talk about the next one? You already said yes.
Yes.
Okay, first things first, guys, use process of elimination. If you don't like C, that's fair, that's understandable. However, there's not anything to eliminate it, right? First off, if we have a correlation from a sample, does that mean we have a correlation for a population? No, so we cannot pick A. B, if the rats stopped drinking the water / caffeine mixture, this would cause a reduction. Why is that a problem there?
Because we did.
We can't.
Was it not an experiment? Oh my god.
It never said it was an experiment, right? There were no treatments, there was no reduction of confounding variables. All right, what about D?
Man, I didn't guess it. Did she talk to
We
me?
can't
can't
assume that
tell
the
if they
rats
don't
might
like
be
it or
in
not.
No, no,
Right.
no.
So, we have no information about that. E, since the correlation is not very high, does that mean it's not linear?
No.
No, it just means that it could be a weak linear relationship. A, B, D, and E are all eliminated. We are left with
I'll
C.
see it
That's
18.
what I did.
I don't know. It just
So-
was, it made more sense than the other stuff.
But right here, guys, hey, right here, language-wise. Yes, ma'am.
Hey, you know, still easier.
Language-wise, what should this language, 18% of the variation in blood pressure can be explained by that linear relationship, what should that make you think of? R squared. That's the language for the coefficient of determination.
So just pop that number out.
No.
Now you plug in the.
The correlation was this. So what is that 0.428? That is R, and how do I get R squared?
Swear it.
I square it, and you know what you get?
18.
Yeah.
So exactly, that's both.
Okay, so,
Oh, it is coming up with this.
nope, not just coming up with it. So pay attention to the language, right? The idea that percent of variation in the dependent variable, the response variable, that can be explained by this linear relationship, that is literally the language of R squared.
What do we use?
Literally, right? And so Bryson, if I have R and I need R squared, what do?
Weird.
Square it, that's it. Okay, yes, Logan.
This is not stats related.
Huh?
It's not stats related, man.
Go for it.
If you gave an Amish person Sprite and said it was water.
So number 10, actually we did very well with number 10. Okay, changing the units does not affect the correlation. By the way, don't forget, this formula right here explains why changing units does not change the correlation. Because what is Z? Hey, Z. Why is that important for knowing it doesn't change the correlation?
Because isn't it just the same thing?
This doesn't look like a.
He doesn't have units.
It doesn't have units. Z is a standardized test statistic. So if we're calculating R, do the units matter? No. So do not forget that detail. Okay. We actually crushed it here. The one mistake that some of us made is whether we picked B or E. But notice, what is my response variable in Model D? Log Y. That's why it had to be E and not B.
What?
Yes.
Second page for this. No, they have the front page.
If you're speaking
Model B,
That's it right there?
No, that's it right there.
Oh, I'm
So there's the question on left. And it goes with this.
Oh.
Alright.
Do we see it now, Bryson?
I mean, I had two choices and then I took a guess between B and E, but I didn't realize it was the same log and that.
So, and here's the thing, this is what I've talked about a lot. On an AP exam, on multiple choice, when you get it down to two things like that, go word by word. Model B is appropriate since the relationship between X and there's the difference,
I found myself doing that a lot.
right? That's what you need to do, word by word till you find the difference. And once you see that, you gotta go, okay, well, what do I have? Log Y.
Jeez, perhaps you got that right.
That's how we do it. All right. Some of us did not read the directions on this one.
I hate it.
No.
See,
What does it say at the end? What would you want to see from each characteristic so you know the line fits the data well?
I hate this.
Yes.
I feel like me saying has good scatter implies that there's no pattern. I feel like I should.
You need both of those. Yeah. You can actually have pretty good scatter and a pattern at the same time.
Okay.
I got like half on all this.
Yeah. So, but what I needed us to know, not define these things, but what tells us if it's a good line. Are there any of these that I need to clarify the language that I used here? D?
And C.
What part about
C and
D? Well, did you look at the language I used?
Yeah, I know.
Okay. But standard deviation, what do we want the standard deviation to be? We want it to be close to 0, essentially.
Oh, low, that's what that says.
Yeah, low.
Yeah.
Drop it
It
low.
says loss.
Logan, you said D? Lexi, is that the one you're asking about? Which one are you asking about?
C.
Well, that's the standard deviation. We want our standard deviation to be as low as possible.
I put 0 and that's questionable.
Yeah, because it's not very realistic that it's 0 because they're scattered, right?
Yeah.
There's almost always going to be some difference from that unless it's a perfect line, and nothing in the real world is a perfect line, right? So, unless we're doing math, and guess what, are we doing math? No, we're doing what?
Science.
Statistics.
Statistics, which is a mathematical science, okay. Coefficient of determination though, right? We want R squared. The
I didn't know that.
R squared is called the coefficient of determination. And we want it close to 1. Where in the world did I get 0.64 from?
It's a great question.
What do we-
Is that the understood?
What's a strong, what R gives us a strong linear relationship? 0.8 to 1. What's 0.8 squared? 164.
Oh.
Right away.
No way.
So that's how I get, and you didn't have to say the 0.64, that was an extra detail that I added, but, yeah. Okay. How are we feeling about those details now? Okay.
Oh.
Okay, don't forget, I am recording, and you can always shoot me an email if you're studying and have a question.
I made so many dumb mistakes on this.
It's okay, learn from it, do better on the test, and you'll be alright. Alrighty here, we have all this information about the elk's chest girth, and so, again, this is where we gotta pay attention. Several of us missed these details, but first off, remember what's my least squares regression, or what's my regression line equation? Y hat equals,
A plus bx.
I gotta remember that, right? B is my slope because it is multiplied by x, right? Constant additive rate of change, that's what a slope is. So A is my y-intercept, right? That's the constant. And so, what's the first question asked before I put the answer up here? Oh yeah, describe the relationship. Most of us got strength, most of us got direction, most of us got the shape, but what other things do we need? Context and unusual aspects, yes.
I feel like you were going to say it, but like, when do we need to say for the usual aspects? Is that the influential?
That's potential influential observation, so potential high leverage point, potential outlier. And so you'll notice right here, I will say this, I would have been okay if you said that there do not appear to be any points that are out of the pattern. I identified this one as a potential high leverage point because it was decently far away horizontally, but you at least have to address it. Even if there don't appear to be any, right? When we do CUS, center, unusual aspect, shape, spread, even if there's no outliers, we gotta say there's no outliers.
Yeah.
Or, does that make sense? Yeah. So, strong, increasing, or positive, I should say, linear relationship between chest girth and weight of the elk. There do not appear to be any outliers or influential observations, maybe a high leverage point. That's an ideal answer, you didn't have to have all that. Okay, but strength, direction, shape, context, and unusual aspects. Go for it, Peyton.
In the case that I cannot see this on the video because I'm gonna go like write all this down, could you email me like the file for this?
Don't let me forget. Like if I forget by the end of the day, shoot me an email so I don't forget. And I'll just send it to the whole class. All right, equation. Be careful. Oh, did I skip the equation part?
It looks like you.
I did.
Dang. Wow.
It just doesn't matter. Just kidding.
Facts.
Just don't do that part.
You can probably just write on the board.
Well, I have it right here.
Sorry, I was thinking of the
I accidentally deleted it. Okay, so the predicted weight, again, could you have just done y hat and x for response and explanatory variable?
Yeah.
Yes. Does this help in making sure you don't make mistakes? Put your variables in there, right? Again, notice 2.8063 was literally the coefficient for the, what does it say in the mini-tab output? Does it say girth? Right? So coefficient for the girth. Constant. And some of y'all did make mistakes in there, and I read with your mistakes, but make sure you update this. Once again, I wrote my slope using the change in y hat divided by the change in x.
Yeah, I totally missed that one.
Bryson, you go with this now?
Wait, which one?
You see how to fix those mistakes? Doesn't matter what happened in the past, it's how we move forward. Right, Aaliyah?
Maybe.
It's how we move forward. Everybody in this class is earning credit on that AP exam. So we fix our mistakes, we move forward, learn from them. So, predicting the weight. Actually, do I need to talk about B and C at all? We good? Say again, Josh. You good?
Yeah.
Okay. D, I know some people were a little stuck on this, but remember, we talked about it again, if we're predicting the weight, that's the chest girth. What's that 200 centimeters going to take the place of?
Okay.
The chest girth, right? The X. So make sure you just substitute it in, make sure you wrote your equation right. But the confidence is probably the issue. Yes?
You wrote extrapolation on that.
Yeah.
Right. A lot of us missed this detail. I want you to go back and look at this. If you look at the x-axis, what is the last data point on the x-axis, or x value? 165? So if we go all the way to 200, is that close to my data?
Not really.
So what am I doing?
Extrapolate.
Extrapolation. When you go too far outside of your data set, what are you doing? Extrapolating. Could that be an accurate prediction? Yes, but if it's extrapolating, it's dangerous. Right, we are not very confident in that prediction because we are extrapolating a good bit. So remember, that was the issue that you had with the population, right? When we had that y-intercept, you're like,
somewhere you wrote the extrapolation should be avoided.
yeah,
On some other paper.
too much of an extrapolation, right? A little bit of an extrapolation, like if I went to 170, maybe 175 centimeters in chest girth, that's pretty reliable because it's close to the data.
How is that just deem it close enough?
Right. They're not going to test you on that on the AP exam as far as I can tell. So don't sweat that. That's more of a like, if you go into statistics, you have to be very careful about how far out you extrapolate. Or collect more data to be able to extrapolate further. Okay? Alright, last couple details. Guys, we gotta make sure we pay attention to the value of R squared. If you need a formula in terms of how we write the variation, that's what number 9 was all about. It's the percent of variation in the response variable that can be explained by the linear relationship between the two variables. That's what R squared is. That's the formula. It's the percent of variation in my response variable that can be explained by their linear relationship. Okay? Last piece before we do some free response and work with each other.
Are we gonna go over any of the other assessments?
The what?
Any of the other assessments we got back?
Those are old tests. We may go over them to review, but that's not to help you with bivariate stuff.
Maybe all
Okay.
of the multiple choices that I missed on that one.
Okay, it doesn't matter.
Alright, right here. No, they definitely matter because you need to score a point or two higher on the AP exam because I don't care if you're getting a 3 to get credit. We want better because we're shooting
You
for
want
excellence.
better.
No,
You want that.
I want better for you because you're capable of more. Show it. Alright, the one thing I need to talk about is the residual. When we say interpret the residual, what does this residual tell us? The fact that it's negative tells me that the actual weight is what?
Is bigger than the.
So remember, here's my actual, here's my,
Oh, and then my
predicted. So the actual weight is 24.922 kilograms below the predicted.
So we had to write that out too?
That is what we mean when we say interpret the residual. So when we say interpret the residual, it's that amount either more than or less than the predicted amount. Okay?
If I use the slope my back page, it would be so perfect.
If what?
If I use the right slope my back page, it would be so perfect.
Yeah.
I just,
But I read with your mistakes, I think, some, didn't I? Yeah. So again, remember the AP exam does read with your mistakes, so just learn from it and move forward. Okay. All right. Now I want to do, the FRQ time, so that's the next set. So, what's the one we didn't do, 2014?
Yeah.
Okay, 2014 is probably one of the best FRQs that we have. What we're going to do to help you prepare, so what we're going to do is I'm going to randomly generate groups of 2. I need you to actively work with each other to grow and to learn.
I'm not working.
Not
with
gonna
someone
have
that's
to
trying to
work.
generate it.
She doesn't work with me.
Well, I
Like,
am,
absolutely.
I help with the other videos.
You'll at least be in these pairs if you choose to not follow directions and choose not to work with your partner. That's up to you.
I'm gonna rely a lot of that part, dude.
Oh, listen, I thought you were going to be early. I thought you were going to be lucky.
Oh, okay, I'm good.
You're good? Is that what you said?
Yep.
Okay.
There's a few people here that I don't know,
Wait,
and
there's
I
one
don't want
person
to
by
know.
themselves.
So let's do this. Bryson, Josh, you want to work on your own, I'm assuming, yeah? Why don't, since y'all are already together, I'll just let you 3 work together. Y'all work as much as possible. Okay. I want responses on vertical surfaces so I know what to address and talk about. So let's see, we'll use this chalkboard, that whiteboard, and this whiteboard. I need you to have 2014 out. I need us to finish this in 20-ish minutes, okay? That's how much time I'm budgeting.
No, I don't even have 2014 anymore.
Dude, I gave it to you yesterday.
Yeah, you was doing 16.4 million papers. I walked in.
Aw, let's complain a little bit more, why don't we?
Let's be organized a little more, don't we?
So, I think we were good on the residual. We don't need to talk about it, do we? So, Bryson, what's the acronym that helps us remember how to calculate a residual?
AP,
AP. What does that mean?
actual minus.
Actual minus predicted. Hey guys, for those of us when it comes to interpreting, I do want to point this out that if you remember actual minus predicted and you look at this number, and because I totally get it, that man, sometimes it's hard to remember if it's above or below, but literally if I look at my actual here, is that value above or below the predicted? That actual is above. So when we interpret it, right, the actual, and that's a Y value, so the actual fuel consumption rate of a car with a length of 175 inches, I'm trying to go to centimeters, but inches is, was it 0.96 gallons above what was predicted, right? So it has a higher fuel consumption rate than what was predicted. Not necessarily something you want. B, okay? So there's two things that I need you to always pay attention to with scatter plots like this, and really this isn't even a scatter plot. What do we have here in graphs 2 and 3?
Residual plots.
We have residual plots. Guys, when you do a graph like this, when you have bivariate data, what are the things you have to pay attention to in order to be able to interpret all this information? What do we call those labels? The labels for the axes, right? That's kind of what I'm really focusing on and trying to get you to, right? And so a lot of us finally got there looking around the room, which I can't really see the green, but I know I heard y'all talking about it. When we look here, right, and I talked about this with all the groups, when I look at graph 3 and I want point A, what are the two things I need to know about that point or that car? The residual, that's my response, and the wheelbase. Right? Make sure you pay attention to those variables, right? Because a wheelbase of 93 means I'm instantly looking here. How many points are even possible? There's only 3 points even possible, right? Use your axes labels, use those values to help make sense out of this. Okay? So, x-axis wheelbase, wheelbase. Now, Aaliyah, what do I still need though to find point A on this graph 3?
The residual from the regression of the SCR.
Right, so the residual, yeah? Okay, so when I look for that residual, where am I going to find it?
The previous problem.
The previous problem, well, when you say previous problem, what do you mean?
That's where we.
From this, I guess y'all did calculate it in
Yeah,
A. I actually just looked right here.
That makes sense.
What is my residual?
We could just.
So we could have just not even done it. We could just
Right.
skipped and looked at
So,
this.
hey, so I need y'all to hear me clearly on this, okay? They did that because if a student is stuck on part A and has no answer, then B is really hard to do, right?
Nope.
But if you have this graph right next to it, can you see the Y value? Right. So it's so that students can still be successful even if they make a mistake on one part.
Nice of
But
Yes.
then you can just take that and be like, oh wait, that's the residual, and then go back and put it for A.
Well, they're going to want calculations and work. And notice it's not exactly 1, it's 0.96. Okay. So there is a point on graph 3 labeled by B. It was very close to the horizontal line at 0. What does that indicate about the FCR, the car represented by point B? Logan, what did y'all say about this point B right here?
Oh, we said it was basically at the residual line.
So, but what does that mean though?
It's an AP SCR.
So it wouldn't be the residual line, it'd be the, there's another R word for the line. It's already G, a regression line, right? But what does that mean? What is that regression line doing? It is, starts with a P.
The same. He said it was basically the same.
Yeah, it's basically the same, but what does a regression line do? It starts with a P. It is, what?
Predict.
It's predicting, right? So this car has a fuel consumption rate very close to what was predicted, right? Go back to what those things are. And you're right, like this would be, if a point was on this line, that means it's on the regression line. But what does that mean? That means that regression line is predicting, is close to the predicted value. We good with that? It's like you had the right ideas, we want to be clear and technical with our language though. Alright. C, write a few sentences to compare the association between the variables in graph 2 with the association between the variables in graph 3. And this is where it's key that we recognize what type of graphs do we have in graph 2 and 3, Bryson?
Scatterplot.
Do we?
Ooh.
Ooh, look again. They're what, Aaliyah? Residual plots. And that's important because we would need to approach them differently. If this was a scatter plot, Joseph, which of these would be better if this was a scatter plot? Graph 2, right? There's at least a somewhat linear relationship.
Is there?
But what do we want in a residual plot? We want there to be a lot of scatter. And so, Josh, did you figure out what I was trying to get you to think about? There's a lot of scatter and no pattern, right? There's a pattern in graph 2.
I just realized.
There's a pattern in graph 2.
Are these discrete or continuous variables?
Well,
Well,
Because
fuel
what about-
can,
you think about engine size, you can't, they just go in ranges
but
or in increments.
it's measured in liters,
So,
It could be.
It's volume.
Theoretically.
so it's continuous.
right.
So here's the thing you have to think about. There are preset engine sizes, but the way that we measure that engine size with liters is continuous.
Alright.
The way that we measure the wheelbase in inches is continuous. Fuel consumption rate in gallons is continuous. It could be any value. Okay. And especially because there's going to be variability. Nothing's exactly the same.
Yeah.
And so it could be on an interval, not discrete values. Okay. Good question though. So when we compare them, we want to think about shape, strength, all those things. Which of these has a stronger? Actually, I won't say that. I will say this. Which is more linear?
correct.
Now remember, this is a residual plot, right?
Yeah.
And so if it's a residual plot, we want more scatter and no.
Pattern.
So which one has more scatter and no pattern?
3.
Graph 3.
But
Gotcha.
I
I
don't like
messed
that.
up on that.
And so that's something we want to pay attention to and learn from.
Right, I was
But that's why you have to pay attention to residual plots versus scatter plots. So graph 3 has a more, what kind of relationship?
Linear.
Linear relationship. And I
You-
think that's all they're going to ask for here.
What threw me off is with the plots, the data points that were like in a curve right there.
So you're talking about in this graph
Yeah,
right here?
yeah.
But remember, this is not a scatter plot. This is a residual plot. So, and that's what I was saying earlier. Scatter. So if this was a scatter plot, this is definitely more linear. But if it's a residual plot, we want a lot of scatter and no pattern. And so if we look at the solutions here, I just want us to see this, right? So part C, graph 2 reveals a moderate association that is positive and linear. But, what? Moderate association that's positive and linear. Weak association that's positive and linear. What was the question? Because maybe I misread it, and y'all are right.
On
Which one?
C? Or if you said just.
I don't read C.
They do say the variables in graph 2 are the variables in graph 3. I hate that.
I mean, like, it's linear, but it's not
Right.
supposed to be.
Well, so what they're saying is you would want to say that there's a linear relationship between the engine size and the residuals, and there's a weak linear association between
Yeah, that
wheelbase.
makes sense.
Huge.
Well, but you're right. I just thought they were talking about the original variables, not the residuals. Okay. So Joseph, I lied to you. My bad, dude. I said I lied to you. They were talking about the residuals, not talking about the fuel consumption rate.
It's a pretty
So
bad
you were originally
question.
right.
No,
My bad.
hungry.
I think that's just a bad question.
That is a bad question,
I kinda
because
rock
that's
with these
not what we
questions
would
six.
usually focus on is the residuals. We would usually focus on the fuel consumption rate.
I'm just gonna, when we get to
Just
the
gonna
test,
skip the
I'm
entire
automatically
exam
skipping.
and just gonna do
What are we
questions.
gonna
That's all you need.
And then not even do any of it.
Now,
Be
hey,
funny.
so stop talking about the bare minimum and shoot for better.
We're kidding. We're not being literal.
Uh-huh.
Deacon might be.
So, yeah,
Wow.
Deacon definitely is. Alright, so right here, do notice, as long as you talked about the description of form and direction, a description of strength, and a comparison, you're gonna earn credit. And so, if you only do two of the three components correctly, you can still earn a P. So we're always wanting to do as much as possible. And if you make a mistake in one part, they're gonna read through it with you, especially when you get down here to D. And so then again, they read through you, or with you. So if you did it incorrectly on C, you can still get D based on what you say in C. I am shocked.
Flabbergasted.
I'm flabbergasted.
Might go to money very quickly.
But
Out
again,
of the wind.
because, well, one second, they usually refer to the original variables, not to the residuals.
Well, this was like 10 years ago, it's practically ancient.
Whoa.
Possibly.
Whoa.
This is outdated.
I mostly just feel bad for lying to Joseph. Forget the rest of y'all. But, I'm just kidding. Alright. So, run to the bathroom quickly. We're going to start the next piece.
I'm just gonna stop showing up.
I thought it was
In a week, I'm not gonna be here.
I was gonna fall on my face in a second.
Oh no.
Okay.
Yeah.
5 more days, I'm not showing up anymore.
5 more days.
The 26th, I have 4 more
No,
days
there's
to my
no-
birthday. I better take you for some.
Graduation, when is that close?
Yep.
For seniors.
I don't know.
Oh, for you?
One page. We're almost done.
What day is graduation?
No idea.
The 16th.
There you go.
Then I gotta do the project.
Hey, do you know what day graduation is?
Alright.
Saturday is my
Well, I guess you're
birthday.
a student, so you.
Ew.
I think it's 6.
Yo, head honcho said we don't have to go to the
I
graduation.
know it's like the same.
Alright.
Well,
Mr.
actually,
Hinton.
I talked to the counselor. She said that we should be done by.
Miss Woodruff said that,
Before.
Hey,
Mr. Hinton said.
Right here, what I said is, we got stats to learn. Thank you. Alright.
Yeah, it's bad, yes, sir.
I'm listening.
Hey, that's an end to the conversation.
Guys.
We got this to look at. So, M&M's. So, according to a well-placed source, the milk chocolate varieties of M&M's from the Hackettstown, New Jersey factory has the following color distributions. To determine if the distribution of colors in our large bag is different than the claimed distribution, we will take a random sample of 60 M&M's from the bag and compare the observed distribution of colors. And so I will say this, I am going to do more than 60 because I'm just going to give you a handful and we'll go from there. But what I want us to think about even before we collect our data, right, is right here, this idea based on the proportions given, what would you expect to see for the counts of M&Ms? So we're going to have different sample size, but let's say that my N is 60 and I have these expected proportions. Bryson, how many of my 60 M&Ms would I expect to be blue?
25, 15.
So 25%, which would be what? 15. So I would expect blue to be 15. Right? Peyton, how many would I expect to be orange?
25%, so 15.
So 15 again, okay. Lexi, how many would I expect to be green? A little bit trickier this time? Any guesses how we could quickly and efficiently figure it out?
Just divide by, just do, yeah.
So we can always use a calculator. By the way, practice using a good calculator. But notice right here what they're saying, Lexi, is half of 25 is 12 and a half. So half of 15.
Would you do 7 by?
Say again.
Why would you do 7.5? Because can you get 7.5 in it?
It's a fantastic question.
Nice, you can.
Because on average,
So it's an expected value. Say it again over here, Deacon.
on average.
On average, right? Can you have an average that's a piece?
No.
I don't
Well, I
think.
mean,
Yeah.
On average, it could be you could get a piece, right?
Average, yeah.
So that's why, Peyton, is we would still say 7.5 because it is an expected amount, not the actual amount.
I'm not
Think
gonna
about those
expect
probabilities,
it.
things like that, right? Same thing. Say again.
I feel like expected value is a dumb term, because I'm not gonna expect anyone to have 7.5.
I'm gonna
Well,
expect you them.
But
If
hold
it's
on,
peanut M&Ms, I'm not eating
Hold on.
peanut.
I am.
I am happy.
Hey.
with it.
excuse me. Expected though just means, like what we expect is the average, is the typical. And if we have an average, right, you can get a part because we are averaging. So that's the whole idea here. So we're expecting this many. And so here's what, man, we may not have a chance to actually get to the M&Ms. That means people on Monday will get to do it as well.
Oh.
My bad. Hey, right here though,
To show up.
this is what I need us to focus on right now. Are you not gonna be here Monday?
I have my gov exam, my chem exam. I'm gonna be gone all day.
That's
The
next
only
week.
AP exams? Oh,
Wait, no.
no,
Monday?
that's in 2 Mondays.
That's in 2 Mondays?
Yeah, not on
Next
Monday.
Monday.
You'll be here. All
Next
right.
Monday's
Hey.
the 29th.
Eyes and ears. Eyes and ears.
Guys,
Thank you. What hypotheses should we make about the distribution of M&Ms?
So, null hypothesis.
Ah, right. So we need to be thinking about null hypothesis. What would be our null hypothesis here?
Wait, do we need one for all of them? Or
Yeah. Are we doing just one proportion this time?
Bro.
2 proportions?
No, it's
six.
We're doing 6 proportions. So what would we
Oh
need to
my
say?
God.
We expect the. What could I say?
you could maybe reduce it to 2 null hypotheses. Like you did like orange.
Yeah, since they are the same
Orange and
value.
blue would equal
So
15.
I'm going to talk about. So first off, I'm going to show you 2 different things. I'm going to show you one of them. First off, should I say P red or P hat red?
Yeah, right. Because you're getting your.
No, P red is
Right.
highlighted. Yeah, you gotta do
I mean, like, it's
population.
all-
Remember, it's a hypothesis test, so I'm not talking about the sample, I'm talking about the population. So the P for red should equal 0.125. And then P brown would equal 0.125. Notice I'm converting it to those decimals. So can you say all that?
Yeah.
Yeah, you could.
That's
What's
the
the way
thing
that-
for
I'm saying
What's the better
like
way?
P red,
I don't know.
comma.
Tell us the better way.
What's a simpler way? What's a quicker way? We're not right on.
There we go. Listen, the simpler way is we want to know how well does our data fit these expected proportions, right? Or these claim proportions. So we can simply say the null hypothesis is the reported proportions are true.
Wow.
So we could write out the AP exam?
Yep.
Yeah. No numbers.
Right? Now, I might put more context to it, right? So the reported proportions for the M&M colors are true or correct, right? So what would be my alternative?
They're not.
correct.
The reported proportions are incorrect. And again, make sure you have context in there. And so here's what I need you to understand in the last minute or so that we have here is when we do this hypothesis test, right? We're not going to be using Z's, we're not going to be using T's because those are for 1 and 2 samples. What we're looking at here is, again, how many proportions? 6. And so we have to change the type of test statistic we're going to do. But also, a big thing I want us to hear is we are trying to see how the goodness of fit. Literally, how well does the sample do what?
Fit the data.
Well, fit the proportions or the claimed proportions, right? And so if we are looking at a goodness of fit test, the claim is that all of them are true. We're testing if that is not the case. So how well does the sample fit the predicted values, the reported values?
We will find
So
out
it's
on Monday.
how good it fits. So we are going to start with a test on Monday,
Whoa.
and then on bivariate data, Scatterplots, the whole 9. And we're going to end with chi-squared stuff. We'll get 1 day of chi-squared and then review.
the.
Because I'm just gonna introduce small things, I'm not gonna test you on this.
Nobody knows about that.
Study,
You wouldn't-
you can do this.
feel
A
like
bio
you were
binder,
I will
a
try.
stat binder, a calc
You
binder.
can do it.
Everything.
You can do it.
I don't care.
Hey, does anybody else have their permission form?
Nah.
Is this signed?
Turn this